Is the star on fire? No, this is a starlight wind. But what is a starlight wind? Let's try to understand that using only two simple concepts. Here's the first thing. While a wind here on Earth typically flows horizontally, a stellar wind is a vertical outflow of matter from the star into outer space. To have such an outflow, we need an outward pushing force that is able to overcome the inward pull of gravity, so that the gas can be lifted up and then ultimately escape. The second thing. Now in our case here, this outward pulling force comes from the starlight itself.
Normally, we don't think about this radiative acceleration in our daily life, right? We know a photon when it hits us in the eye, but we know it from the energy. We can see exactly. We don't really know that we also get a kick. Yeah? When the photon hits us in the eye, we get a little kick, and we always have to fight against it. But it's so few photons around here, relatively speaking, that this doesn't matter. But for very, very luminous systems, like accretion disks around supermassive black holes, or the very most massive stars in the universe that I study a lot, there, this radiation force is critically important.
So this strong radiation force makes these superstars lose an Earth mass or even more from their surface every single year. So in that sense, perhaps it's a good thing we don't live around one of them, because if we did, we'd constantly be hit with like 1 billion times more particles than what we are today. And that would quite likely not be such a pleasant experience.